Yeah, it's good. All right, so these notes are called partitioning of a line segment notes. Partitioning of a line segment. It says to partition a line segment means to divide the line segment into the given ratio. The two numbers in the ratio must add together to equal the total number of pieces. I know that's a lot of words for y'all, but I'm going to show you what they're talking about. Got some examples down here. Y'all should know what ratios are because we just worked on them last week. But look at this first one. It says label point P that partitions this line segment AB into a ratio of 3 to 2. Before we even start with that, let's talk about this. You got a full line segment here, AB. How many small segments do you see? Last class they told me 4, 5, and 6. How many little small segments do you see? You should see 5. Y'all that are seeing 6, let me show you what y'all doing. And I don't know why y'all count like this. Y'all counting the dots. You can't count the dots. The dots are like y'all counting like this. 1, 2, 3, 4, 5, 6 dots. No, it's the space in between. See 1, 2, 3, 4, 5 segments. Y'all okay with that? Okay, so it's 5 segments there. You agree? They want you to split it, that line segment AB into a ratio of 3 to 2, going from A to B. So where would I put point P at? The partition point. You put it on yours and I'm gonna put it on mine. We'll see if we put ours in the right spot. My partition point, I put mine right here. For me, this will split my line into 3 and 2. Have 3 segments here. And then I have 2 here. Y'all okay with that concept? Once again, I asked you how many segments we have all together? 5. We're going to need that number for later. So we got 5 segments all together. The second one. It says label point P that it partitions the line segment AB into a ratio of 1 to 4. So put P where it's supposed to go. It's 1 to 4. From A to B. Point P should be here. 1 segment versus the other 4. Once again, your total number of segments, you can just add the 2 together. It's 5. Next one, you AB into a ratio of 2 to 3. Put point P on. It's my partition here. 2 to 3. Gesundheit. Same situation. I know all those are easy because, I mean, we're using the same 5 segments every time. It's not going to be 5 segments every time. It's going to switch up. Matter of fact, let's see if y'all been paying any attention just now. Let's start with Christian. I believe in this kid. Christian, the next one switches around for us. It gives us our partition. It wants to know what the ratio is. It says determine the ratio of the directed line segment AB when partitioned by point P. What ratio would you write here based on the way this line segment looks? Go ahead, give me the first one. Which one, bro? 1 and 2. Ratio is 1 to 2. Everybody see why that is? You see how many segments we have, right? 3. All right. Deontay, do the second one here. Determine the ratio of the directed line segment AB when partitioned by point P. Say it one more time. 2 to 3. Good. Might as well. Bobby, last one. 5 to 1. How many segments you have in total, Bobby? Good. If y'all can get that, y'all can understand the work for today. It's going to be pretty simple. I wanted to say something else about this. Oh, yeah, this is what I wanted to say. Now, what you're going to need to pay attention on when we get to the actual work, sometimes it switches. It doesn't always go A to B. Sometimes they'll ask you for the partition from B to A or whatever 2 letters you have. They'll go in the opposite direction. It may say B to A. So say, for example, on this one that Bobby just did, say if instead of saying segment AB, say if it says segment BA, they want you to partition that one. And looking at this, what would your ratio become if you go BA? 1 to 5. Y'all understand? Okay. Alright, so the steps for partitioning a line segment. This is for when you're doing it on a graph. Most of this is going to sound familiar because most of it's stuff we've already done. Step 1, determine the total number of parts of the line is divided into. So easy, you just got to determine the number of parts the line has. Step 2, determine the length of the horizontal and vertical distances from the end point to end point. That part right there, step 2, that's something we've been doing all year. That's what we do before we do Pythagorean. Remember we create that triangle? That's all you're doing right there. That's you creating right triangles. So step 2, under that I want you to write, just so you'll know, make a right triangle. When you make the right triangle, that's going to help you get your horizontal and vertical distance. Step 3, divide each length by the total number of parts found in step 1. And in step 4, count from either endpoint the number of parts used to form the ratio. All right. So let's do it on the back. Do 1 and 2 with you. After I do these 2, you're going to be off at the races. All I did was show some of them, number 1, and they took off on me. Given the points A 3, 4 and B 6, 10, find the coordinates of the point P directed line segment AB that partitions AB to a ratio of 2 to 1. Before we even graph anything, ratio is 2 to 1, so how many segments are we going to have? 3 segments. You might want to just label that at the top of yourself so you make sure you know 3 segments all together. And then from there, let's graph those 2 points. A is at 3, 4. B is at 6, 10. So A is going to be here. B is here. Draw your line segment in. Use some kind of straight edge. It's going to help. Because if you use a straight edge, you're going to line your stuff up right. Alright. Then from there, make our right triangle so we can get our horizontal and vertical distance. Right triangle, I'm going to do it from A to B. Ain't got to be pretty. And I'm going to do my counts. Tabitha, what's the horizontal distance? She even paying attention? All right. Thanks a lot, Tabitha. Even if you weren't paying attention, you could just look up, yeah. I did it for you on the board. All right, we don't have that kind of time, and we're recording. Why are they horizontal? 3. Vertical. 6. Alright, so those are my two numbers I'm going to use. Out to the side to show your work. Well, we don't have space out the side. Let's do it on top right here. On this one, we're going to do it up top. Horizontal. For horizontal, I'm going to just put H. Just so I know this is my horizontal I'm finding. Horizontal is 3. But if you look at step 3 on the front, it says divide each length by the total number of parts found in step 1. How many parts do we have? How many segments do we have? So take the horizontal distance divided by 3. 1. That's going to tell you how many units to move. So I'm moving 1 unit horizontally. And then vertically, 6 divided by the total number of segments, 3, which is what? 2 units. So that's just telling me how to move. So I got 1 unit for my horizontal, 2 units for my vertical. So check me out. To find my partitions or my segments, going from A, I'm going to move 1 unit to the right horizontally, then 2 units up, 1, 2. It's my first point. Second one, 1 to the right, 2 up, 1, 2. It's my other point. These are my partition points right here. You just got to decide. After that, it says partition it 2 to 1. So put your point P in the right spot. Make this AB 2 to 1. It's going to be right here, right? Point P will be here. And then you just got to tell me what point P is. What is point P? Point P is at 5, 8. So P is at 5, 8. And that is you partitioning a line segment. Yeah. Only time it gets harder, and listen, some of y'all are going to say, oh, I don't need to do all that to partition my line segment. But listen, shh. Some of y'all are going to try to do it without showing the work that I showed up here. When you get to the ones where it's a decimal, you're going to need to do what I do up here. It's not always going to be whole numbers. On this worksheet, I think most of them on here are, but when you get to the practice, it's not always going to be whole numbers. Don't try to cheat the system. Do what I do, man. Number 2, this is the only other one I'm going to show you, and I'm going to make you do 3 and 4, and I'm going to walk around and see what you get. 2, given points A at -3, -2, and B is at 6, 1. Find the coordinates of P on the directed line segment, BA. I'm underlining this because if you see it, it says from B to A. That partitions BA in a ratio of 1 to 2. Alright, so graph the points. So it's -3, -2. That's A. Next point is at 6, 1. 6 up 1. That's B. Draw your line. Try to make your line straight from dot to dot. It's going to help out when you partition. Alright, from there, make your triangle. Now on this one, listen to me. They said B to A, so I'm going to make my triangle from B to A. I'm going to start here, come back this way with it. That's fine. Even if you do it the other way, it's going to be okay still. I just rather do it this way if they tell me B to A. So when I do my count, I count the right way. What's the distance from horizontally? Somebody counted that? 9? It's 9. Vertically? 3. I forgot to ask y'all starting out, but we can calculate it now. How many segments do we have in total? 3. So 3 segments. Alright, so do your horizontal and your vertical. Horizontally, it's going to be 9 divided by 3. 3 units. Vertically, it's going to be 3 divided by 3, which is 1. And do you do your count to get your points in? Nope. Shh. I'm going this way. I'm going to the left 3. 1, 2, 3. And then I'm going to go down 1. down 1. Then I'm going to go to the left 3 more. 1, 2, 3, down 1. Give me my points for my partition. Now you need to understand, they told me B to A. So they want me to partition this 1 to 2 from B to A. So where's my point going, my P going to be at? Give me the actual coordinate, yeah. Yeah, it's going to be at 3, 0 right here. This is where P is going to be at. Because from B to A, I'm splitting it into 1 to 2. Yeah, sorry. I'll make it a better P. Alright, so point P will be at 3, 0. Like I said, the only time it gets any tougher is when you have decimals. But you'll be able to figure that out too. Do number 3 and 4. I'm coming around and see what you get. Do 3 and 4. Let's go. Alright. I'm about to stop.